Today I'm going to talk about environmental factor on aquaculture, which is temperature. The effect of temperature on water quality, the growth and metabolism. Different measurements of water quality are influenced by temperature. Less dissolved oxygen is present in warmer water, which can result in hypoxia and oxygen deprivation. The solubility of gases, the cycling of nutrients, and biological processes in aquatic environments are all impacted by temperature, which may change the chemistry and general quality of the water. For the growth and metabolism of farm organisms, temperature is essential. Specific temperature ranges are optimal for each species' growth rates, feed conversion rates, and overall performance. Lower temperatures may impede these processes, whereas higher temperatures seem to encourage faster development and metabolism.
Ammonia is one of the environmental factors in aquaculture. The presence of ammonia in aquaculture may be harmful to fish and can affect their growth. Ammonia usually caused by nitrification, the death of algae, decomposition of uneaten food, and also breakdown of chloramines. We can notice the signs of ammonia by seeing the fish body color get darkened and their gills will be red or bleeding. In addition, the fish will swim erratically and more quiver when netted. However, we can control ammonia by reducing pH and temperature, decreasing stocking density, and using biological filtration.
Hi, so today I'm going to explain a little bit about environmental factor that will affect the aquaculture system. First of all, the aquaculture sector is particularly vulnerable to natural and human-induced rapid or slow onset disaster. This is due to the risk associated with infrastructure, the type of activities associated with fish farming, the nature of fish in specific development stages, and the limited capacity of the sector to reduce and cope with the potential consequences of a disaster. This complexity presents unique challenges in terms of preparing for and responding to disasters. The sector is impacted by a wide range of disasters, including, for example, droughts, earthquakes, floods, landslides, storms, tsunami and tidal surges, and more. Because aquaculture is so heavily dependent on reliable natural resources like water, the possibility of major catastrophes to aquaculture during natural disasters should be considered. So farmers should prepare for natural disasters through proper facility construction, developing a disaster management plan, having emergency backup equipment on site, contacting owner companies to get on a service priority list, and considering insurance to provide some disaster relief.
Habitat destruction. This activity of expanding the areas of land and water used for agriculture and using more intensive methods are two ways to boost production. This will increase cultivated area extension, whether on land or in water, as a result of higher inputs, typically result in conflicts with other resource users. Aquaculture facilities that are large and crowded frequently produce pollution that severely damage habitats. While mangrove forests in Asia and Latin America have been bulldozed to make way for farms, some European fish farms have been built in the wild salmon's migration path. If aquaculture farms are not sited properly and correct managerial protocols are not strictly followed, long-term cage operation can cause detrimental impacts to the seafloor and to critically valuable environments. There are a few solutions in faces these environment factors. First, avoid disruption to native biodiversity, especially protected species. Second, a generally accepted distance from corals is 200 meters to have minimal impacts on water quality, venting environment and sensitive habitats. Third, site farms away from corals, seagrass, mangrove and other sensitive habitats, and make sure that gear and moorings are not damaging habitats.
Pollution. The meaning of pollution is harmful materials that into the environment. There are many various types of pollution, but in aquaculture, we are focused on the water pollution. Water pollution can occur when the harmful substances contaminating the water sources such as lake, river, stream, or pond. These substances come from the factories that release the toxic substances into the river illegally. In aquaculture, water pollution is the main thing to avoid because it can affect the fish itself and can lead to the profit loss. So aquaculture businessmen must secure the water that comes into the pond, and that water should be polluted free.
Next, I am going to talk about challenges in aquaculture, which is food production, feed availability, and cost. Aquaculture species require specific types of feed to support their growth and development. Ensuring a reliable supply of high-quality feed ingredients can be a challenge, especially for carnivorous species that require fish meal and fish oil. Additionally, fluctuation in feed prices can significantly impact the profitability of aquaculture operations.
Water quality plays an important role in aquaculture. Overall fish health and performance depends on the water quality. Inadequate water quality causes more losses than any other problem. This means that we must understand the water quality requirements of the fish under culture very well. Different fish species have different and specific range of water quality aspects such as temperature, pH level, and use of oxygen within which they can survive, grow, and reproduce. Each species has its own optimum range. It is important for fish producers to ensure that the physical and chemical conditions of the water remain within the optimum range of the fish. Outside this optimal range, fish will exhibit poor growth, erratic behavior, and disease symptoms or parasite infestations.
Aquatic pollution is the example of challenges in aquaculture. Aquaculture pollution through eutrophication is an unfortunate side effect of a rapidly growing and under-regulated industry. The emissions of marine animal waste from aquaculture facilities into the ecosystem will not only affect other fish but will also result in nutrient pollution. For example, one of the most harmful aquaculture system is open net cage farming, which often takes place on the coast of large bodies of water. It involves the use of large mesh fishing nets to hold the farm fish, and there is no way to prevent waste from escaping into the water. This waste can contain antibiotics, pesticides, and fish feces, which pollutes the open water and makes it unsafe for human drinking, recreational use, and for the other wildlife. The best methods to prevent soil and water quality problems include selecting a site with appropriate soils and an adequate water supply, and maintaining moderate fish densities and feeding rates. Secondary management techniques to prevent soil and water quality imbalance include liming, fertilization, and aeration. Agricultural irrigation, created wetlands, settling basins, and biological filters also are practical methods for improving the quality of effluents from ponds.
Disease. The main source of economic losses in aquaculture is disease issues. The most significant cause of disease issues in all kinds of production is bacterial infections. Almost all cultivated species have epizootics due to gram-negative bacteria. The second largest cause of losses is, particularly in the culture of salmon and crustaceans, is fungi. So, the solution is maintaining proper water quality, feeding, and sanitation practice in order to preventing fish disease.
Water abstraction. Water abstraction describes the procedure of taking water for use in aquaculture operation from a natural source such as rivers, lakes, and groundwater. The regulated production of aquatic species such as fish, shellfish, and aquatic plants is known as aquaculture. Water intakes for aquaculture production are associated with water abstraction that can contribute to decreasing groundwater levels and low flow situation in rivers. There are many effects of reduced groundwater such as groundwater storage resources may be run out. Other than that, habitats that are relying on rivers and wetlands could be affected by the reducing of the groundwater. Lastly, the cost of purifying and extracting water might be rise